Dear students, you all are aware that in the revised pattern of engineering services 2017 of UPSC, in the stage 1 there are 2 papers. In paper 1, the topic general studies and engineering aptitude, which is common to all branches: civil, mechanical, electrical, electronics and telecommunication. As part of this general studies and engineering aptitude, there are 10 topics. Of them, the basics of material science and engineering is included. In order to give a brief introduction about this topic, I invite Professor Kameshwara sir to deliver a lecture on this.
My dear young friends, those who are aspiring to appear for the engineering service examination of 2017, you are aware that the UPSC has modified the recruitment process. There is a 3-stage process. The first stage, which has got 2 objective papers, one is on general engineering aptitude, which is common to all the branches, while a paper 2, which is also objective in nature, which is discipline specific. While the syllabus for the branch specific papers have been given by UPSC, for the general aptitude paper in your stage 1 has not been specified by UPSC. So I am going to brief you the most probable and the expected syllabus for the topic on basics of material science and engineering. As you will find, in general, you are expected to have a qualitative understanding of the basic materials which are commonly used by any engineer in his day-to-day profession. So normally you are expected to be the form of electrical materials, dielectric materials, magnetic materials, composite materials. In addition to that, the recent developments on the nanomaterials, the smart materials and also superconductors. We can in general look at the most probable topics of importance under this paper. So mostly they contain, as you find, 6 chapters, or we can divide into the first one being on crystal structure and defects, the second one being on electrical materials, the dielectric next, the magnetic, the composite materials, and of course the nanomaterials. Now let us look into briefly the topics which can be expected under each of these chapters and some probable questions which you can expect from this one. So as you find, you are expected to know the basic knowledge on crystal structure, which all of you have been exposed to in your first year course of the BTech program actually. So which has got the space lattices, the unit cell, the different structures, etc. And you can expect an elementary questions on these things, which has got on, as you know, to find the number of atoms in the given FCC unit cell. You can find on the close packed structure in these things, as you know, obviously the FCC. Similarly, the crystal structure of the most widely used electronic material, namely, as you know, silicon, the second being, as you know, the diamond cubic. Similarly, as a matter of fact, you should know more, a little more about the crystal structures. In that case, you can expect the question of the kind like the available space in FCC structure, or the coordination number in the BCC. As you know, the answer being the 8. Similarly, the number of Bravais lattices in, let us say, a cubic system. So here you should know that not the total number of lattices, it is a purely in a cubic system. How many are there? We are asking. The answer being 3, as you know. The next we look at the topics on electrical materials. As you notice, the basically the conductors, the Ohm's law, the specific resistance, the high conductivity in the low conductive materials. You get solder materials, alloy conductors are there, and the semiconductors, and of course application of all these things too, like LEDs, the solar cells, etc. You find one of the standard questions normally we come across in the conductors being which is having the highest conductivity. Obvious answer being, as you know, the silver is the one having the highest conductivity of all the metals available. Similarly, silicon, as all of you know, is a semiconductor in these things. In a similar way, what is that we are using as a filament in all the cases, whether in the case of your valve tubes or any other filament in your electron tubes, etc. The answer being, all of you know, the tungsten, the only metal having the highest melting point, used extensively as a filament element. If you look at another type of questions, like you find the charge carriers and conductor, which all of you very well know, the electron charge carriers. Similarly, what happens with respect to a semiconductor when taken low temperatures? The basic idea being, since we will be using our various electronic devices at different temperatures, so we will have to know the variation of their parameters with respect to temperature. So if you look at the semiconductor, and if I take it all the way up to absolute 0 Kelvin, what happens? So obviously it becomes a perfect insulator, and otherwise the conductivity becomes 0 in that case actually. Similarly, if you take the case of an application of these like LED, the LED, as you know, has a conversion in this form, whether it is from light to electricity or heat to electricity, etc. By the name light emitting diode, it has to emit light obviously. So something is getting converted to a light energy. So the electricity to light is the answer in this case, the C being the answer. Next, similarly, if you can come across the questions of this kind also, given a few statements to pick out the correct statement is again in one of the most what we call mostly asked questions in these cases. Like if you take the case of an insulator, it is a wide band gap, its valence band is completely filled and another is a containment empty. The third sentence is in a semiconductor a large free electrons are available in the conduction band. The fourth question, as you know, statement is a conductor has a narrow band gap. Out of these things, which are the correct one, let us look at, as all of you know. The first one, insulators are basically characterized by a wide band gap obviously. You look at the second statement, if you look at it, it is a completely filled valence band and the containment empty, which is again an obvious answer for any insulator as it is. But you know the third, and you will find, after all, it doesn't have that much of electrons at all in this conduction band. So therefore, the statement is wrong. The third one again, as you find, the narrow band gap, we say, conductors have what you should know very clearly, there is no distinct gap at all actually, both the valence band and the kind of overlap in that case actually. So the answer obviously, as you find, the first and the second one are the correct answers, you will take the mark A. Similarly, another common questions we come across, the fundamental law of electricity, namely the Ohm's law. So where exactly we can apply? So as you find, is it universally applicable or a limited application, as you notice? So obviously the fundamental law of Ohm's law is applicable to all the materials in the first place. But as you note the alternative given actually, the first answer is applicable to conductors. Yes, it is applicable to conductors. Is it applicable to semiconductors? Yes, it is also applicable to the semiconductors. Can you apply all the metals? Yes, it is also true. But the fourth statement says only to metals is not correct. So therefore, the correct answer for this question, as you know, you have to choose not just one. The first is that the C is the correct answer for this case. Now let us look at this kind of one, the gallium arsenide. at least electronics people should be at least knowing that nowadays along with the silicon and germanium, one of the most extensively used semiconductor is a gallium arsenide, because it has got a very nice band gap which can be easily even modified. So therefore, it is actually a semiconductor answer. The next one, as all of you know, by N-type semiconductor, so you should be, from your fundamental knowledge, a P-type and N-type semiconductors are existing. So in N-type, a majority carriers are electrons, and you had it in a P-type, you know, it's a whole majority carriers. If you look at the Hall effect, again another fundamental effect related to the semiconductors obviously. So which again, an effect which has to do with this, we can say. Now let us look at the third class of material, that is what called and dielectric materials. Another a very useful and extensively used one with the typical applications. You find the polarization, the dielectric strength is required, the breakdown, the loss, the ferroelectrics, the piezoelectrics, and again they are also known as smart materials. The transducers are there. Then again applications of these things, etc., to the day-to-day applications. Now look at the following. As you know, which materials can exhibit the phenomena called a polarization. In this dielectrics, it is a creation or processing a dipole moment as we call, and they are based upon a polar and a non-polar molecules as we obtain. So you know, a polar molecule is one with an asymmetrical arrangement of atoms, while a non-polar one has got a symmetric arrangement. So if you look at these four all given to you, whether methane CH4 or you take CO2 or CCl4, you have a symmetrical arrangement, so they are not polar actually. Therefore, if you look at the B CCl, which is an asymmetric one, there is the polar molecule. So similarly, if you look at the quartz, one of the very extensively used and everybody knows about it is what is actually nothing but, as you know, a piezoelectric, because piezoelectrics are also known as the smart materials, I told you. So this is another one, a quartz, which everyone knows as it is one of the cheapest metal available in nature and which is used extensively a piezoelectric. Similarly, one of the parameters characterizing a dielectric is the dielectric constant actually. It is always, as you know, the value should be a greater than 1 for any material. Now let us look at some examples of these kind of materials. So how do we go for? Apart from quartz, we also have got other materials. In the piezoelectric, the lead zirconite, you come across the PZT normally in the short form, which is one of the most extensively used piezoelectric. Similarly, a ferroelectric material, if you look at it again, another very useful material, a barium titanate, all of you know. The next is what happens when you use a dielectric capacitor. You know, one of the important uses of a dielectric in the case of our system is to increase the capacity of a capacitor. With the first, in fact, the definition comes from that only. So as you know, what is the effect of a dielectric in a capacitor? Obviously, to increase, answer A being to increase the capacity of the capacitor, this one. Next, if you look at this, let us see how do we exactly produce a fundamental application in ultrasonics actually. As you know, one of the most extensively used diagnostic system is using ultrasonics. And how do you produce these things? One of the very elementary ways is using a piezoelectric crystal once again. Similarly, you are using every day the most of the automobiles, whether a scooter or for anything, you need obviously a spark plug to ignite. And what that you are using in a spark plug, which is nothing but again you come across a piezoelectric crystal is used in that case. Again, if you have got an earphones everybody using for these things, a microphone we are using in our day to day. So what exactly we are using in that case again for the transducer actually. Here again you find a piezoelectric crystal will be used as a transducer in these cases. Now let us look at another class of materials, what is called a magnetic materials. As you know, the one again another extensively used material in the case of the data storage, as all of us know, is the magnetic disks and magnetic materials actually. So you have to know how do you characterize these things actually. So we do it by the phenomenon called magnetization. Another parameter, the susceptibility. then we classify these things based upon the susceptible value, as you know, dia, para, ferro, etc. And again we are distinguishing them as a hard and soft materials, and of course their applications. For example, if you look at what exactly the metal used for the permanent magnets of these cases, you know, in this case first cobalt is purely only simply a magnetic one, cannot be highly. Nichrome is no longer a magnetic, it is a heating element, as you know. Constantan is again another heating element only. The all-nico alloy, one of the best and the extent used material to produce permanent magnets is the all-nico alloy. Aluminum, nickel, cobalt alloy, short form is all-nico alloys. Similarly, as I said, we are distinguishing these things into a dia, para and ferromagnets actually. So what is the effect of a diamagnet when you place in a magnetic field? As all of you know, a diamagnet weakly repels any magnetic lines of forces. So the answer will be the A being the answer in this case. Now as another parameter, as I told you, the hysteresis behavior, again a characteristic of only ferromagnetic metals and not all actually. The dia and the para, they do not exhibit this one, only ferromagnet exhibit this what is called extra behavior. So obviously answer being the C in this case, as you know. Again, how do you characterize any ferromagnetic material with respect to, as I said, a dia and para, because it is a spin of these atoms which get a parallel orientation, giving rise to an enormous amount of dipole moment. So we will characterize them in the form of if any ferromagnet will find a large number of equivalent parallelly aligned spins actually. So the answer being as you know A. Next, coming to these material used in the case of a transformers. You know, any transformer which is used as a transferring an energy. So what should be the core of a transformer should satisfy? As you know, it must have a very high permeability and at the same time a low losses. This being because when you use an alternating voltages, you should have a very quickly magnetized and again quickly demagnetized. So from that point of view, we look for a very high permeability, and always there should be a very low loss should be there during the energy transfers. So the answer being the B will be the correct answer for such a kind of a question. Look at the next one. As you know, one of the most used the data storage, as you notice, is the magnetic tapes. So what exactly we are using in a magnetic tape? What material actually? Magnesium oxide cannot be ceramic obviously. Cupric oxide is also again nothing to do again an insulated material. Purely carbon cannot be used. The iron, as all of us know, is one of the magnetic materials actually. But iron, cobalt, nickel, they form the triplets of the ferromagnet in this case in periodic table. So therefore Fe3O, the ferric oxide, is the one which is used in magnetic tapes actually. Now let us look at in the last few decades, the extensively used material in the case of construction industry, in automobile industry, etc., is the composite materials actually. And what are they basically? Mostly the polymers, which are again further classified in the form of the plastics and thermoplastic materials, then reinforced composites, your FRP, fiber reinforced plastics, and again you have got the structural composites and of course their applications as you look at it. So nowadays, as you know, there is a ban on using a plastics actually. Then what actually you can use or permitted to use actually basically. So obviously we distinguish the form of two varieties. One is called an LDPE and then HDPE. So what is LDPE polymer? It is a low density polyethylene. So C will be the answer, as you all know. You not ethane, the ethylene when you polymerize you get a polyethylene, which is a low density this one. So which is used as an LDPE. A HDPE being, as you know, a high density polyethylene. And these things also are used as an insulating material in the external actually. So what exactly the most commonly used insulation in these cables? which all of you know is a PVC is one. Wherever you find insulation cables for any of these electricity, the PVC cables are the widely used, other you don't come across anything else being used on insulation actually. That is because of their very good insulation capacities and properties. They can even withstand to a good extent the temperatures also. Then you have polymers, as all of you know, and what exactly their characteristic. Polymers by their very nature, they are very light, and at the have got a very high strength also. So therefore they are melting, but they can very easily melt. They are currently only low melting point they have got, but at the same time they have very high strength they have got. They can carry a good amount of strength. Now another, as we all come across or use, as you know, everyone lives in what we call RCC building, as we call. Then what will the RCC mean actually? It is a reinforced cement concrete. It is quite likely they can ask this kind of what you call abbreviations of the questions actually, which you normally use in any of these cases. The RCC is one standard used everywhere, so you should know the expansion of being the reinforced cement concrete. Similarly, latex, another one. Latex by the name, as you know, is a rubber based one, and wherever there is an insulations are used, even normally in the diagnostics or even hospitals, they use a gloves actually. It is not a pure rubber, it is a latex as we call, which is derived mostly from the rubber material actually. That polymer is a latex as we use. Similarly, we need to have an insulation of both the things. One is a vacuum insulation you will require, you have a thermal insulation you require. In those cases, we use a gasket for these things. So what exactly basically made of? Most gaskets are basically a rubber based one. So therefore the answer being rubber. That can withstand better than the nylon, a polyester or PVC actually. So gasket, rubber being a flexible, mostly used in the form of a gasket material. Again, if you want at high temperatures and insulation, what can we use? Because it is possible during manufacture we have to provide an insulation high temperatures actually. So the silicone rubber is one of them which is extensively used at high temperature applications. Now you look at again the recent range we can say the nanomaterials. So what exactly a nano? A nano, as all of you know, is the nanometer is a 10 raised to minus 9 meter, as you know. So any material falling under the category of nanometers means they are like up to a less than we can say 200 nanometers of size. We call them as a nanomaterials basically. So usually this ranges maximum 1 to 100 nanometer, we call them as a nanomaterial. The first A being the answer. And from where it actually arises from, the one of the earlier the allotropes of carbon, as we can call. Earlier they were known only, as you know, a graphite and a carbon and diamond they were known, but then recently it was the buckyball model of the carbon isotope. This one allotrope was found out, and that is having a single molecule made up of 60 carbon atoms, and that is also called a fluorescence because the whole structure one unit cell appear in the form of a football actually, having this many atoms found together. Similarly, in fact these nano were in fact first identified even the normal laboratory by collecting the soot on a glass plate, and that is a carbon when it is deposited, it forms in the form of nano actually. So therefore we find even the nano particles were used or were coated on the swords used by the Tipu Sultan. And what is that material actually? That actually a carbon was used in a nano. Similarly, what exactly which makes these nanomaterials to succeed and to have such a special properties actually? One fundamental property being the surface area to volume ratio is very large in these cases as other things. So the one which really distinguishes a nano from other materials is the surface area to volume ratio, and as you find that is the deciding factor for the efficiency of any nanomaterial. Now look at the conductive device. The same element, even in the form of a nano, you find it has got 1000 times more conductivity than a normal copper as it is, and you can understand the kind of benefits you are going to reap from this kind of one. Similarly, any nano already told you is due to the large surface area they possess in these cases. Now look at this, these are some of them, carbon nanotubes are formed, they are merely graphene as they are called, and we have got a hexagonal shaped rings actually. And another, the standard preparation technique we use in the case of a nanomaterial actually. What does it mean? You can either a top down approach, that is on a bulk one, you reduce it, bring it to a smaller one, or you sound basically small atom by atom, you collect and coalesce together and form a nano. And which is the most commonly used if you look at it, the bottom up approach is the efficient and also very economical, and you can do in a large scale, we can produce it. The answer being the B is the answer. Now let us look at the different kinds of problems you may come across in these cases. Like sometimes you will have a match of following kind of one, where you will have to match the corresponding answers from this one. Look at this example. We have in the list 1 gives you a biotechnology, a material science, and infant technology is there actually. The list 2 lists out another 4 products. One is the quantum dots, another spintronics, another gene therapy, and was swarm robotics as you find. So all of us know the biotechnology as it is related to a gene therapy. Well, material science you may think of the spintronics, it is actually to do the quantum dots, and your IT relates to the spintronics. Okay. So as you find 1 to C, 2 to A and 3 to B is answer being, you find the C is the answer in these cases. Now another kind of a similar one, as you find you have got a nano shell, a hydrogen atom, E. coli bacteria, and a transistor. How exactly they match? Remember, nano shell is almost a size being 100 nanometers actually, as I told you, within that actually should be. A hydrogen atom is an angstrom unit. 0.1 nanometer is nothing but 1 angstrom. So therefore, atom comes with D, it corresponds to. What E. coli bacteria, which is size actually, the standard is 2 micrometer is the size. E. coli you can find nothing but 2000 nanometer is the size actually. Transistors are formed around 90 nanometers size of any transistor normally formed. So you find the C being the answer in these cases. Now you can come with this kind of an odd man out kind of one. So given the 4 alternatives, you can find which is odd. So proportion limit, yield point, they are all related to obviously any stress strain curve you must have learnt actually. The odd point being the fracture point. There is nothing like a fracture point existing anywhere actually. Similarly, if you look at the general usages, what is the first material used by a man from the ancient actually? The rock was the first one used as a material by a man in this case. Then the first metal which was known to the man is only iron was known to them in the earliest case. Now this is another a simple one, namely you have got the question on this one. You only to know the conversion from the units they are given this and that's all, which you should be familiar with the conversions. And this again normally any engineer should know the units in which you measure a certain quantity. So here you find in force should be used in Newton, which all of you know yes, but the energy is measured in, dynes is the CGS unit of the same force only. Energy is not measured in dynes, you should know it. Current of, as you know, measured in unit of amperes is correct. Now fourth one, as you look at electric power is measured in kilowatt hour, it says, it is again a wrong answer. Electric energy is in kilowatt hour. Electric power is only what is energy power. So therefore you find the answer being 1 and 3 are the correct answers. You find the B is the correct answer for this one. And you can also come across this kind of one, a reasoning statement and assertion statements are given to you and identify these things. We give an example for this one. For example, you take the example, insulators do not allow the flow of current. The second says there are no free charges. So first statement is correct, the second is also correct, with a correct estimate for the first one. So we say the answer is A. If it is the second one, tungsten is a filament in bulbs, it has a low melting point. The first estimate is correct obviously, the second one is a wrong answer. So you go for The first assessment first is correct, the second wrong means C is the answer in these cases. Look at this one. Computer hard disks are made of magnetic materials. Second states directors are capable of storing information. What about the two statements? The first one is correct, the second is also a correct statement obviously, but the second one is not an explanation for the first one obviously. So therefore you find the B has to be the answer. Similarly the other two also you can say the first one is a correct given statement which is correct, the second is also supporting and explanation for the first one. So in this case again answer being the A in the two cases. Thank you very much. These are some of the reference books I have given you in these cases which will be quite useful in this moment. Thank you all.
This topic, the basics of material science and engineering, is included in stage 1, paper 1 of general studies and engineering aptitude. Even though the UPSC has not explicitly come out the specific syllabus, our team of subject experts, professors, based on their experience, arranged the syllabus in a structured manner, not only the syllabus but also the probable question. I feel this particular topic is relatively easy and highly scoring. A serious IS aspirant, I hope, will definitely get some enlightenment from this particular presentation. To win the race, join ESE.